Dear students, today I will discuss with you some important MCQ from the chapter solution. The first question is, one component of a solution follows Raoult's law over the entire range 0 to 1. Okay. The second component must follow Raoult's law in the range x2, range where x2 is what? So see, when one component follows Raoult's law, the solution is ideal. Okay. The second component will also follow Raoult's law, the same concentration. So same concentration means your C, D is the same concentration. So x2 lies between 0 to 1. Okay. Yes. So choice D is the correct answer. Next, the vapor pressure of a solvent decreases by 10 mm of mercury when a non-volatile solute was added to the solvent. The mole fraction of the solute in the solution is 0.2. What should be the mole fraction of the solvent if the decrease in vapor pressure is to be 20 mm of mercury? So how can you do? You see, there is a rule. You see, delta P, that is decrease in pressure, by delta P dash is equal to x2 by x2 dash. Okay. So decrease in by first 10, then second one decrease by 20. So by 20 is equal to, what is x2? x2 is 0.2. So x2 dash is what? You calculate x2 dash, it is your 0.4. Okay. So first one is mole fraction. We know both mole fraction is 1. So x1 dash is equal to 1 minus x2 dash. So 1 minus 0.4 is equal to 0.6. So 0.6 B is the correct answer. Okay. Next, 18 gram glucose is added to 178.2 gram water. The vapor pressure of water in torr for this aqueous solution is how much? Okay. So you have to change these two by mole or mole fraction. So you see, 18 gram glucose, molecular mass of glucose is 180. Okay. So 18 divided by 180 is equal to 0.1 mole. Similarly, water, 18 gram glucose is added 178.2 gram of water. So water molecular mass is 18. Okay. So mole fraction 178.2 divided 18 is equal to 0. So it is your 9.9 mole. Okay. Yes. So now calculate the mole fraction. Okay. So mole fraction of water, mole fraction of water is how much? Mole fraction of water is 9.9 divided 9.9 plus 0.1 is equal to your 9.9 divided 10 is equal to 0.99. Okay. So vapor pressure of water in aqueous solution, vapor pressure of water in aqueous solution is equal to mole fraction of water multiplied vapor pressure of pure water. Okay. So you will get mole fraction of water 0.99 multiplied vapor pressure of pure water 760. So you will get how? 752.4 torr. So choice C is the correct answer. Okay, next, which of the following statement about the composition of the vapor pressure in ideal solution, the 1:1 molar mixture of benzene and toluene, this is 1:1 molar, okay, is correct. Assume that the temperature at constant temperature, that is 25 degree centigrade, vapor pressure of benzene at 25 degree is 12.8 kilopascal and toluene is this much. So out of the choices, this is the one choice. The vapor pressure will contain equal amounts of benzene and toluene. Second choice is not enough information is given to make a prediction. Third choice, the vapor pressure, the vapor will contain a high percentage of benzene. Fourth choice, the vapor will contain a high percentage of toluene. So out of these, which one will be the correct answer? You see, where here is given the vapor pressure of benzene is 12.8 kilopascal. So if the vapor pressure is high, then your partial vapor pressure is also high. So out of the choice, the vapor will contain a high percentage of benzene. So choice C is the correct answer. Next, 1 mole of liquid A, 2 mole of liquid B make a solution having a total vapor pressure of 38 torr. The vapor pressure of pure A and pure B are 45 torr and 36 torr respectively. The describes solution, these are the choices. Is an ideal solution, shows negative deviation. C is a minimum boiling azeotrope. D has value greater than the sum of the individual volumes. So you see, we will calculate according to Raoult's law. You see, PA is equal to mole fraction multiplied PA 0. Okay, partial pressure. This is pure solvent. So this is XA is given, that is 1:1 1, and C, it is 1 mole of liquid A, 2 mole of liquid B. So it is 1:2, the total mole is 3, 1 is 2, so total is 3. So 1/3 of XA multiplied, partial pressure is 45 torr, so you will get 15 torr. Similarly for PB, this is 2/3 multiplied 36 torr, it is given 36 torr is given, so it is 36, so you will get it is 40 torr. So total 15 plus 24, it is 39, but it is the total pressure is given 38 torr. So this is the negative deviation, shows negative deviation. Okay, yes, choice B is the correct answer. Next, which one of the following is incorrect for ideal solution? So these are the choices given. This is enthalpy of mixture is 0, and this is internal energy, change in internal energy of mixture, it is 0, and delta P, it is your observation value minus calculated value, or Raoult's law, it is 0, and delta G, free energy, delta G is free energy of mixture, delta G is free energy of the mixture, it is 0. Okay, so out of the choices, which one is correct? Given following is incorrect, it is asked which one is incorrect. You see, for ideal solution, for ideal solution, okay, delta H of mixture is equal to 0, delta U, that is internal change in internal energy of mixture, is equal to 0, and delta S, enthalpy change of mixture, it is not 0. Okay, so delta G of mixture is equal to delta H of mixture minus T delta S of mixture. So it is 0 and T delta S it is not 0. So you will get it is delta G is not 0. It is not 0. So choice D is the incorrect. Okay, choice D is the incorrect. Next, the vapor pressure of acetone at 20 degrees centigrade is 185 torr. When 1.2 gram of non-volatile was added dissolved in 100 gram of acetone at 20 degrees centigrade, its vapor pressure was 183 torr. The molar mass, that is gram per mole, of the substance is what? Okay, so you see how you will do this. So it is the formula P0 minus Ps by P0. See, this is known as the relative vapor pressure. Relative lowering vapor pressure is equal to, it is your N2 by N1, mole of, these are the mole ratio, and this N2 is equal to W2 by M2, weight of the substance by molecular mass, and W1 by M1. Okay, so it is 185 minus 183 P0 minus Ps by 185 is equal to your 1.2 by molecular mass. You have to calculate W100 gram in 58. Okay, so what is 58? Acetone, the molecular mass of acetone is 58. Okay, so by solving this you will calculate M2, that is 64.38 gram per mole. Okay, so choice 64, choice D is the correct answer. Okay students, have a good day.